Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This lecture is focused on more about angles, specifically coterminal angles. You should have a strong familiarity with angles. You don't have to actually have watched my creating angles video, but you do need to have a strong familiarity with degrees and radians and how to convert between the two. Not strong, but you should have recently watched that video. How's that? And in this video, we'll talk about something that we've already seen, which is the fact that every angle has many angles that lead to the same terminal side. And that's basically what this definition is telling us. Two angles in standard position having the same terminal side are called coterminal angles. And we saw that, I think, in a previous example, but I'll make one up here. So for an example, let's say you have an angle that opens up, and I'm going to keep it real and have us go into radians here. So let's say that this angle is 7 pi over 6. Notice I don't have a degree sign on there. It is just 7 pi over 6, which means it's a radian angle. And you know that pi, since 2 pi is 360 degrees, you know that pi would be way over here at 180 degrees. So this angle there is pi. Pi is the same thing as 6 pi over 6. And we want to go to 7 of those pi over 6s. So we are just a little bit further than 6 pi over 6. We're 1 pi over 6 beyond that. And by the way, we had already shown in the previous video that pi over 6 is the same thing as 30 degrees. So we happen to be 30 degrees beyond 180 degrees. So here we are, at this, I missed it again. That angle right there. I'll erase that. So that angle is 7 pi over 6. Now, coterminal to that angle is a negative angle. This negative angle right here. That negative angle is negative. Well, it almost went to negative 6 pi over 6. But it's just shy of that by a single little, I'll draw it in blue here, a single little pi over 6. That's what this short trip here is. So if we're almost to 6 pi over 6, but we're backing off of it by a single pi over 6, we're at 5 pi over 6, but it's negative because we're going negative direction. Remember, clockwise rotations are negative. So this is a negative, 5 pi over 6. I want that in red. So this is what I mean by two angles being coterminal. They share the same terminal side. So they are coterminal. So 7 pi over 6 and negative 5 pi over 6 are coterminal angles. That's a good example. I need to speak slowly because there's not much in this video. It is very short. So the theorem here, any angle that I hand you has infinitely many coterminal angles. Well, the proof is very easy and it actually illustrates how to get to coterminal angles. So given some angle theta, it could be in radians, could be degrees, but let's pretend it's in radians. Why not? Then given that theta plus 2 pi is also coterminal, lands at the same spot basically. So if this angle here was theta, let's just pretend, then going to that angle, theta, and adding another 2 pi to it, which is a 360 degree rotation, lands us at that very same terminal side. And in fact, you could add yet another 2 pi to that, or yet another 2 pi to that, and you would still be at the same terminal side. Or you could technically have this angle theta, and you could say, well, let me get to theta, but then I'll subtract 2 pi. and I'll subtract another 2 pi, and I'll subtract another 2 pi. Essentially what I'm saying is you can add or subtract any integer multiple of 2 pi. And the way you would note that is theta plus 2 pi k, where k is an element of, that's what this means, I'll point that out, is an element of, there we go, is an element of the integers. That's the set of integers. Set of integers. There we go. And this notation is super popular, so you have to get kind of used to it. So for example, that's the end of the proof, by the way. There's not much to it. For example, actually, I have a bunch of examples. Hold on. I say I have a bunch of examples. I'm just going to make them up. So state 3 angles coterminal to the given angle. I'm going to give you some angles. So part A. Let's pretend as though the angle I hand you is, let's make it actually one of the most important angles in trig. Theta equals 30 degrees. And you want to state 3 angles coterminal to that. Well, one angle is theta is equal to 30 degrees plus 360. Notice I'm not mixing angular measure. In other words, I'm not mixing degrees and radians. If you start in radians, stay in radians, at least when you're adding, subtracting, stuff like that. So this would be 390 degrees. That is coterminal to 30. Let's see. How about 30 degrees minus 360? That's a negative 330 degrees. What else? Well, there's not very many choices. You either add or subtract a multiple of 360. There's just nothing else you can do. So, 30 plus 2 sets of 360. And so that's 720 plus 30, that's 750. There you go. That's how you get coterminal angles. Let's do one in radians. So let's suppose that they give us an alpha angle, and that angle is negative 5 pi over 6. Actually, you know what? I played with that. Let's do negative 3 pi over 4. All right. So negative 3 pi over 4 is the angle they hand us, and they say, by the way, the question could be asked a lot of different ways. Find the first positive coterminal angle. Okay, fine. Let me add 2 pi to that. So, by the way, I shouldn't have labeled these thetas. Theta 1, theta 2, theta 3. So this is alpha 1. So this is a second, another angle that is coterminal to negative 3 pi over 4. So if you add 2 pi to that, you'll rotate from a negative 3 pi over 4, which is actually right here, and you'll rotate all the way around to the first positive value angle that lands with the same terminal side. Thing about radian measure is that you have to get common denominators. So the common denominator here is obviously 4. So this can be 8 pi over 4, and then you just add them up. So that'd be 5 pi over 4. And it turns out that is absolutely correct. If I want to land right here, I would rotate from the positive x-axis past 4 pi over 4 all the way to 5 pi over 4. A second angle that is coterminal to negative 3 pi over 4 is negative 3 pi over 4 plus 12 sets of 2 pi. Right? It's any integer multiple of 2 pi. So I just made my life a little bit difficult by creating such an insanely large number, but that's okay. It's negative 3 pi over 4 plus 48 pi. Or I'm sorry, I say 48, it's 24. I'm thinking of something else. 24 pi. And then, of course, you have to get a common denominator, which is 4. So 4 times 24 is 96. And now you can add them up. That'd be 93 pi over 4. And, well, you get the idea. Now, on the homeworks that I'm building right now for my students, they have things like find an angle that's coterminal to 1001 degrees. I mean, it's some silliness like that. Or they say find the first positive coterminal angle to that. That means that you have rotated around past 360, past 720, and some more, right? So you want to basically start unwinding that spool. So if this was the angle they handed you, I'm going to start by saying, okay, what's 1001 minus 360? If that doesn't get me to a small enough value, and I'll just quickly compute that. So it's 641 degrees. If that's not small enough, if that's not between 0 and 360 degrees, subtract yet another 360 degrees. So subtract 2 sets of them. That's degree sign right there. So if you subtract yet another 360, or if you do that, it becomes 281. And that 281 degrees is definitely between 0 and 360. That's generally what like an online homework system would ask is, hey, could you please state the first positive coterminal angle? If you try to subtract another 360, it'll get negative. So yeah, there's a lot of these styles of problems, but coterminal angles are incredibly important because you could be dealing with the sine or the cosine. Whoops, I shouldn't have said those words, right? Because you're in trig, but you haven't learned those yet. But the fact is, you could be dealing with a trigonometric function of a very large angle, and it would be really nice to reduce that very large angle to a smaller number. And I just spent a moment or two looking through my homeworks that I assigned, and yep, these are kind of the questions I asked. So perfect. All right, that gets us done with coterminal angles. And like I said, very important. Hopefully that helps you in your course. Hopefully it helps my students. And I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.